Julie Sandrock, and in this short video, I'm going to be covering space sustainability, reuse and recycling in space. This is part of the CTE Momentum Your Place in Space Challenge. Water recycling on the International Space Station. This is our first example that we're going to look at. The International Space Station relies heavily on advanced water recycling systems that purify wastewater, including sweat and urine, into clean water for drinking and other uses. This is a prime example of a closed-loop system that minimizes waste and ensures sustainability. So here we can see, in terms of this graphic, there's two systems here. There's a water system in the blue, and then in this pale gray, here we have the gas, or let's say clean air system that gets recycled. Water recovery system assists with actually scrubbing the carbon dioxide out of the air, and also the hydrogen that is taken out of the air is assisted in terms of the chemistry of purifying the water. So there's absolutely no way that any water can be thrown out of the International Space Station. There are regular supplies of fresh water coming from planet Earth, but the thing is that it's just really heavy to move and it ends up being very expensive. Because there is microgravity, or effectively very, very little gravity on the International Space Station, we need to use technologies like distillation and reverse osmosis, because we cannot rely on normal filtering systems as we would. Let's say, for example, if we were to use a sand filter on planet Earth or even on Mars, what we're relying on is the gravity, the water actually sinking through the sand filter due to gravity. But when we don't have gravity, we need to use other technologies like reverse osmosis, which relies on surface tension, as well as distillation, which is all about evaporation and condensation. The second example we're going to look at is MOXIE. The Mars Perseverance rover included the MOXIE experiment. In Mars 2020, the Perseverance rover carried an experiment called MOXIE to Mars, and MOXIE is an acronym for Mars Oxygen In-Situ Resource Utilization Experiment, which converts the abundant carbon dioxide in the Martian atmosphere into oxygen. This is a crucial step in preparing for human missions to Mars, because we're going to be needing the oxygen, and resupplying from Earth is going to be way too challenging and expensive, and also literally it's going to take a long time. So this is a photograph of the rover, and here in this graphic on the right hand side we can see this is actually the process of MOXIE. So we can see here that there's an intake from the Martian atmosphere, where MOXIE is collecting carbon dioxide from the Martian atmosphere and then electrochemically splitting it into oxygen, O2, as well as carbon monoxide. And what it does is it's not taking all of the carbon dioxide and splitting it, it's taking a portion of it and splitting it into oxygen and carbon monoxide. The oxygen is then analyzed for purity before being vented back out to the Martian atmosphere, along with the carbon monoxide and other exhaust products that there may be. Then what happens is there's these electronics over here which are analyzing the process, the effectiveness of the oxygen production, as well as the oxygen purity. And then what it does is it's exhausting it. So what have been the results? Well, so far the device has produced a total of 122 grams of Martian oxygen, which is twice as much as the scientists predicted. So using only these two examples, what we need to do is, in terms of the CTE challenge, we need to consider how we're actually going to convert this into a service or a product that can be used in the space industry. So what you'll need to do in terms of your submission for the CTE challenge is you're going to need to look at the application of the technology and will it scale. It's relatively easy to build a desktop model in a laboratory But when it actually comes to scaling a process, that is when it gets really difficult. So you need to have a look at, will we be able to scale it? In other words, will we actually be able to use it on a space station, on the way to Mars, or on the surface of Mars? In space, everything is scarce. And that is livable area, breathable atmosphere, drinkable water, edible food. Everything is scarce, as well as energy. We need to reduce mass of everything that we're transporting because we need fuel for that. So the business models are very different compared to on Earth. And what I'm saying by that is you're going to find that there are some products and services that are only affordable if they're used for space applications, because they wouldn't be affordable by the general populace on our home planet Earth. And then the third consideration is, can it be done without human intervention? So if we have a look at that MOXIE experiment, that is being done without human intervention. It's the rover on Mars, Perseverance, that has actually started the process, that is managing the analysis and actually sending the data back to Earth. And finally, here are a number of links that you can go to, and it's covered in depth in the description of this video.